3 graphs. It's brought to you by the Brainy Couple. So open the description below for more information. Hello everyone, so today our lesson will be on interpreting frequency graphs, cumulative frequency graphs, and box and whiskers plots. I'm sure that after previous lessons you have come to understand what is a cumulative frequency graph. And so for here, we'll go straight to our lesson. So the main thing is, why is there such a need to know all this? Because sometimes the question may give you, let's say I have a question. Yeah. So this question is, it shows that it's the 3 cumulative frequency curves for the results of 3 different math examinations are shown below. So all 3 examinations are attended by the same 1,000 students. Now, how do you know which is the more difficult and which is the most challenging and which is the least challenging? Okay, especially if the median is the same. I'm sure all of you must be thinking, oh, okay, let me check the median first. But in this case, I would say, okay, what if the median is around the same? Then how will you know which? So you can no longer use the median to gauge like that. That's why you need to understand the box and whiskers, how it looks like in the cumulative graph and how this graph looks like in the box and whiskers program. Okay, so now I'll actually go through a theory first. So okay, so you can see that I'll be going through a few graphs over here, and it's a lot of graphs, but don't be scared. So because the idea is actually around the same. Once you know how to understand the graph, then everything will be very easy. So usually they'll give you the middle graphs, like for example cumulative frequency graph. Right? They'll show you this shape. So you should when you see this shape, you have to understand. Okay, this shape means for the frequency graph, it is actually skewed to the left, meaning that most of the students are actually scoring very at the low side of the marks, as you see over here. Usually if you see that the graph is like this, it's slanted in this way, it means that everything is skewed to the left, and the majority of the marks are is at the low end, although you can see it's not that low. Okay, so the thing is, the easiest thing is when you have this graph, you plot the box and whiskers plot using the 5-point system, or using the minimum point, which is here, the 0. So everything is at 10, so this is why the minimum point is at 10. And then you have the lower quarter, which is 250, about 30 here. And then you have the median at the 500 mark, so it's about 35. And then you use the upper quarter at the 750, and then you have the 1000, the maximum. So now that you know how to draw the box and whiskers plot, then you should be able to immediately translate this. This will be much easier to see. Convert this thing into your frequency graph. So for this graph, right, what does it represent for the first graph when you see this graph? Okay, let's say this is the results for a test paper. Okay, so from the graph you can know that most of the students, the results are skewed towards the left, meaning most of the students are scoring on the low side. Okay, so you can say that actually this is a very difficult test where most of the students are actually scoring like below the passing mark. So this is a very difficult test. Okay, then for this graph, the results is quite evenly distributed. So I would say this is a average test. It's not that difficult, not that easy also. So there's a whole wide range of results. And of course, what's the difference between the second and the third? This would be a test which is not that difficult, meaning it's like you can score, but also not that easy, meaning even the smartest people cannot score well for it also, right? It's like compared to here, you can see that there are smarter people scoring better, but then looking at here, okay, let's use this. Looking at here, you can see that most of the smarter people, they are able to score, but for here, the smarter people are not able to score as well. Okay, so this, at the end of the day, you have to look at it, stare at it yourself and try to understand, because it's you taking the exam. Okay, so for this graph, right, you realize, as I said previously, there are two hips, so there are two bumps. So you can say that for this test, this is a test where you have two different levels of people taking it, meaning you have the beginners taking it, which is why it's like you have the beginner class, and you have the elite class, and then you have the not so elite class, the not so smart class, the smart class. Okay, so that's why you see two hips. And then we'll go on to other graphs. So okay, I'll go through this graph first, which is, as you can see from, okay, this one I arranged it a bit differently. So firstly, you'll be given this graph, and if you look carefully, if you plot it, you realize actually this is quite evenly spread out. I mean, as you can see from here, but the so-called evenly and symmetrically spread out actually means it's quite an extreme case. Okay, if you compare this one with this one, yeah, if you compare this one with this one, this and this, you can see that actually they are like the opposite, right? That this one is bent down in this way, but this one is bent up in this way. This one is bent up, but this one is bent down. So of course the box and whisker plot is also different, right? Where you have everything bending, so you can see the range is bigger, and according to a frequency graph, is that this is a very extreme case. So for this exam, right, this is the kind of test paper which is that either you know how to do or you don't even know how to start. It's that either you know how to do and you can score very well. As you can see, there are a lot of people scoring very well, or you don't even know how to start, and there's a lot of people also not knowing how to start. So these are the either you know it or you don't kind of questions. And then we have again here is a graph, just smaller. Okay, here we have a graph which is okay. Here we have a graph where it is skewed to the right. Actually, how do you know whether it's skewed to the left or skewed to the right? Well, of course you can use the numbers, but sometimes if you don't have numbers, or you just want to see it very fast in one whole stroke, you can actually compare this with this, right? So you can see that this is skewed to the left. So now you have all the graphs. Okay, so these are some other stuff that I have for you later. Okay, so as you can see over here, yeah, this is skewed to the right, this is skewed to the left. It's like this whole thing is bending outwards, and this whole thing is bending inwards. So okay, so you can say it's steeper over here it's steeper at less than the medium side. It is deeper at more than the median sign. This is also another way you can tell. Okay, so sometimes you may have a very weird graph. Oh, a straight line. So how does it actually look? It means that everything is constant. So I think by now you should know how to plot the graph, how to plot the frequency graph from the cumulative frequency graph, right? It's through the use of gradient. As you can see over here, it's that your gradient is almost constant, right? Your gradient is almost constant from 10 to 90. And at first it is 0, so when it's almost constant, everything just shoot up like that. Okay, so sometimes you cannot just rely on the box and whiskers plot. You have to look at the graph and plot out the frequency graph. So for this one is a special case where you can say that everything is not skewed. The graph is not skewed, but the results are actually shifted. It's a normal distribution results, meaning everything is well spread out, but it's shifted to the low side. So I would say maybe this is also a difficult test. Yeah, this is a difficult test where none of the students are particularly smart to get the high marks. Okay, so part 2 of the videos will show how we solve the question. So click next. It's brought to you by the Brainy Couple. So open the description below for more information and a note.